This is section 3.3. We are going to be solving systems of linear inequalities. The homework is 28 through 33. A little bit of vocabulary. A solution of a system of linear inequalities is an ordered pair, an x and y, that is a solution of each inequality in the system. A system of linear inequalities is a set of two or more linear inequalities. All right, so first thing we were going to do is check to see if an ordered pair or a point is a solution to a system of linear inequalities. If you remember doing this with systems of equations, you took the point, you plug it into the system, and you check to see if it works. Well, you're going to do the same thing here. So if I'm trying to figure out if the point 0, -6 is a solution to this system of inequalities, I'm going to plug the point in. I have to plug the point into the top one, check to see if it works. I have to plug the point into the bottom one, check to see if it works there. So right here, so here's my top inequality. I have the point 0, -6. I'm going to replace my x value with 0. I'm going to replace my y value with -6. Be careful when you're plugging in negatives. You do have to plug in negatives in parentheses. And I do have a subtract and I do have a negative. Subtract and negative. Make sure you do both. So here you have 2 times 0, which is 0. We don't need that. Subtracting a negative is positive, so we have 6 is greater than or equal to 4, and I want you to tell me whether or not that's true or false. Is 6 bigger than 4? Yes, it is. So then you're going to take that same point and you're going to plug it into the other inequality, and we have replace our y value with -6, replace our x value with 0. 2 times 0 we don't need. And is -6 smaller than -6? No, it is not. So therefore, if even one of them is false, then the whole thing is false or not a solution. So let's do an example. I have the point 7, 5, and I need to check it in this system, so I'm going to plug it into the top equation first. So replace the x value with 7, replace your y value with 5, and 2 times 7 is 14, and 14 subtract 5 is 9, and there's no simplifying that can be done with this inequality anymore, so I'm checking at this point to see whether 9 is greater than or equal to 4. 9, that is true. 9 is bigger than 4. So now I'm going to check the inequality, or the point in the other inequality. So what was my other one? Y is less than 2x minus 6. I'm going to replace my x value with 7 and my y value with 5. Okay, and simplify each side. 2 times 7 is 14. 14 subtract 6 is 8. And this says, is 5 smaller or less than 8? And that is true. Since they were both true, the answer to this question is yes, it is a solution. All right, graphing a system of linear inequalities. So the first thing you have to do is graph each line on the same coordinate plane. So here we have each of these inequalities. So let's see what the first one was. First one was y is greater than or equal to -2x. Y is greater than or equal to -2x. You can think of this as +0 because it doesn't have a b. So you can think of that as +0, which means you start here, okay, you put a point there at 0 for the b, And the slope is -2, or -2 over +1. So from this point, you're going to go down 2 and to the right 1. Okay. Since it's greater than or equal to, the equal to part means draw a solid line. And then you have to check to see which way you're going to shade that line. Now normally we choose 0, 0 as a test point, but we cannot choose 0, 0 this time. Unfortunately, our line actually goes through the point 0, 0, so we cannot choose 0, 0 as a test point. So pick some other point, it doesn't matter what. I don't know, let's pick the point 2, 0. I just randomly chose that point. So this is the point 2, 0, that's my test point. My y is going to be 0 then. -2, my x value is 2. And I want to check to see if this is true or false. So simplify each side. -2 times 2 is -4. Plus 0, we still have -4. And the question, is 0 greater than or equal to -4? And it is. Since it is greater than or equal to -4, you're going to shade covering up that test point. So that's over here. Now I'm shading and I can't shade lightly because, I'm on the smartboard, but when you shade, you're going to shade lightly. You're going to use a pencil. Make sure you use a pencil for this section with their homework because you are going to have to erase. So make sure you shade lightly. And the other inequality, x minus 3y is less than 3. I know a lot of you want to solve for y and graph it that way. I do not recommend that with inequalities. You're going to goof it up because of the inequality. So your best bet, since it is an inequality and it's in standard form, is to use the xy chart. So you're going to pick your x value. We choose 0 because 0 is the easiest number to plug in. So I'm plugging in 0 for my x value. So we're just trying to find a point on the line. So we don't need to worry about the 0. Minus 3y. And I apologize for that. That should be equal to, when we're finding points, we should be equal. Equals 3. And I have -3 times y, opposite of times is divide. And so I get y is equal to -1. All right, so that's one of my points, 0, -1, which is right here. And in order to graph, you actually need 2 points. So 0 is the easiest number to plug in, but we already picked 0 for x. So this time we're going to pick 0 for y. I'm going to plug in y equals 0 this time. And check to see what our x value is. So -3 times 0 is 0, and we don't need that. And again with the inequality, what am I thinking here? When we're doing points, it should be equal. All right, so we get x is equal to 3. So x is equal to 3. And that gives me another point, which I can't see because I shaded over top of it, right here. Okay. All right, so then, since it is less than and not less than or equal to, we do draw that as a dotted line. And we're going to pick a test point. And since our line does not go through 0, 0, we are going to pick 0, 0 as our test point. We always pick 0, 0 if we can. So we're going to replace both the x and the y with 0 this time when we're doing our test point. 0. And simplify each side. -3 times 0 is 0. 0 subtract 0 is 0. So is 0 less than 3? And it is. Since that was true, we're going to shade covering that point. Lightly, remember, shade lightly, shade lightly, shade lightly. Okay, we're almost done. We're not done, but we're almost done. Now, at this point, what we need to do is check to see where the shading overlapped. Where did we have both colors? And if you have colored pencils for this, that's great because it helps you out. Where do we have both colors of shading? Well, that's in this area. I know you can hear that. This area right here. Okay, so you're going to shade that darkly, and then anything that does not have shading of both colors, or overlap of shading, you're going to erase. So erase, 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 and this would be your answer. All right, we have example 3. Y is less than negative 2x minus 2, and y is less than x plus 5. We want to graph the system, so I have to graph both inequalities on the same set of axes. They're both in slope-intercept form, which is nice. Graphing in slope-intercept form is much easier than graphing in standard form. So for the top one, my y-intercept is 0, negative 2, so I'm going to put a point on the y-axis at negative 2. And my slope also happens to be a negative 2 over positive 1. So from this point right here, from the point that we just plotted, we are going to go down 2 and to the right 1, which puts us right here. It is not equal to, so dotted line. Okay. We need to shade. Make sure you shade, so you're going to pick a test point. The line does not go through 0, 0, so I am going to use 0, 0 as my test point. So I'm going to plug in 0 for x, and y is 0, smaller than negative 2 times 0, subtract 2. All right, negative 2 times 0 is 0, and 0 subtract 2 is negative 2. So the question is 0 smaller than negative 2? And that is no, it is not. So our test point was here, but that gave us a false, that gave us a no. So instead of shading on top of covering this point, we have to shade on the other side of the line from that point. So opposite side of the line is over here. So here's where I'm going to be shading. Now I need to check or graph this inequality right here. The y-intercept is 5, 0, 5. So on the y-axis, I'm going to put a point at 5. And my slope is a positive 1 over positive 1. So that means I'm going to go up 1 and to the right 1, which puts me right here. Again, it is not equal to, there's no line underneath that symbol, so it is going to be a dotted line again. 0, 0 is a test point. 0, 0 is a test point. 0 less than 0 plus 5. And simplify each side. What's 0 plus 5? It is 5. The question is 0 smaller than 5? And yes, it is. So my test point was here, and I got a yes. Okay, so yes means shade covering up the test point. Okay, and the answer. The answer is where the green and the blue shading overlapped, which is in this area. I'm not going to go and shade it, but that area right there. So anything that doesn't have double shading has to get erased. So we're going to erase all of this blue here. And we got to erase this little bit of green right here. And that would be our answer. We're getting up there into that 15-minute cutoff time. I always cut it off at 15 minutes, or try to. So I'm going to stop here, and there will be a part 2.